Welcome back, CEA. I hope I have a couple fun days planned for you guys. We're going to introduce some roof types today, and then from there, we're going to move into our first civil engineering and architectural modeling activity. It'll probably take you guys a couple days, but I think you guys will have fun with it. And I'll show you the guys a little demonstration before we leave today of the one that I just created. Before we do that, we are going to dive in. We're going to introduce those roof types, and then I'm going to let you guys create one of them. All right, guys, so right now we're looking at 2.1.2. This is the roof systems. We're going to build on our wood frame systems from yesterday. And as we get to the end of this activity, you guys are actually going to try to do an architectural model of one of these roof systems. So please try to pay attention to the content because you guys are all going to have to use it as soon as we finish here. So again, 2.1.2, and we're going to talk about a handful of roof systems. There are a lot of different types that designers or contractors can build with. Some of those are going to depend on cost, maybe the type of area they live in. Certainly need to have a right type of roof or slope if we're talking about snow loads and things that we might have to carry in this area. So the presentation we're going to look at for this is down here under our resources, and it's our residential roof types. All right, so some things we're going to introduce here real quick. Roof shapes, roof types, different roofs in architecture, different materials we can use, roofs as a sustainable space, Energy Star roof systems, difference between trusses and rafters, as we mentioned quick the other day, a roof pitch, building codes, and again, roof pitch and materials. All right, so the shape and type of roof we have will protect our occupants from a lot of different things. So that could be things like wind, rain, cold, sun, heat, dust, etc. They also add to the visual appearance of your house. A lot of the ones we see in this area are gable roofs. They're pretty simple, cost effective, and that's probably why we see them the most often. The more elaborate roof styles we see, in the case of a couple of these images, you could certainly imagine the cost of that structure would go up significantly. So the main types of roof types that we're going to talk about, and these are what you're going to use to create your architectural model. We have a shed roof, a gable roof, a hip roof, a gable with dormer, a low slope, sometimes referred to as flat, a gambrel, a gable and valley, typically happens when two gables come together, and a hip and valley, maybe when a gable enters a hip or a hip and hip together. Roofs as a sustainable space. Natural light creates a pleasant space for occupants and requires less energy for lighting. In some cases, we can also get some solar gain through those windows and help to heat that space. But natural lighting really creates a nice environment and atmosphere for anybody in there. Energy Star roofing system. So if we know anything about Energy Star, certainly moving towards efficiency. And if we can be efficient, we should be saving money in the long run. There might be a little bit more cost up front, but in the end, after time, hopefully you get that money back and you've been efficient in the process. So energy collected from the sun can be used in that structure. Different things we can do as well. We can block some of that sun through different things we have in the structure. So when we talk about different types of trees, we can get trees that lose their leaves in the winter and allow the sun to come through, giving us solar gain. We'll get into some more of that type of stuff later. Reflective roofs reduce cooling energy costs. We see a lot of the metal roofs nowadays have an Energy Star rating to those. They are efficient. So roof trusses. These are a simple assembly of framing members forming some sort of triangular shape. Uh, when they're pre-manufactured, these are typically considered trusses, and we see this representation down here in yellow. This is a roof truss. Okay, this whole system here, not just a diagonal piece, but the combination of these other components as well. And if we know anything about that, the triangle, it forms a very rigid and strong shape. When we have those pinned together at each end, it really can't lose its shape. Rafters. So rafters are a little bit different. When we talk about rafters, it's going to be this single member that we have here. Okay, these are typically built piece by piece, and then to create that triangular shape so that we can hold that shape, we use what we call a collar tie. Often have a ridge beam that runs through the center here, and if you look close, you can see that running through the center down through this image up here as well. Ceiling joists. We heard the term joist the other day talking about our subfloor. So if we had a conditioned space or space we'd use up here, this could also be a floor joist. When we talk about roof pitch, this refers to the slope of that roof. We have two things we call or talk about when we do this. It's rise and run. Okay, so how far it rises over the distance that it travels horizontally in its run. So rise is vertical, run is horizontal. Okay, so an example, a 712 or 712 pitch means that the roof rises 7 feet or 7 units vertically for every 12 units horizontally. Okay, so again, 712, the rise is 7 and the run is 12. So some common residential roof covering materials. I think the most common we see around here are shingles, asphalt shingles, and probably some sort of metal seam roof. They stand up really well in the climates that we have up here. And some other roofing materials that we might see, maybe a little bit more common in the south, where they have a lot of heat and they have to hold up to that constant sun. We have things like clay, slate, and then maybe even some wood cedar. All right, building codes. I think we mentioned this really quick early on, but we haven't really got into it. Building codes are extremely important with anything that we do. Okay, they're going to be a set of rules that really keep people safe. That's what they're there for. We have international building codes that most things are built off of, and we certainly have those for our residential structures that we're going to get into. They will basically identify the minimum regulations that you can use in a building system. That doesn't mean you can't oversize things or over-engineer. It would create a factor of safety, and even the minimum regulations basically have that factor of safety built in. It also dictates a minimum roof slope by any finished material. So for instance, I believe a metal roof, the minimum slope is a 1/4 pitch. Okay, so it's got to rise at least 1 foot for every 4 inches or 4 feet horizontally. So International Residential Code for 1 and 2 family dwellings. Asphalt shingles, roof slope 212 or steeper. Clay, 2.5 per 12 feet horizontal or steeper. All right, shallower slopes obviously require or will hold more load, and we may end up have more snow or have more rain that would want to settle there if we have those lower slopes. All right, so slate and slate style shingles must be a 412 or 33% slope. Wood shakes 312, which is a 25% slope. And if you think about 3, it goes into 12, 4 times, which is a quarter, 25%. And metal roof's going to depend on the type of metal roof. There are some different types, but that is also fairly low. Okay, it might be 412 if I'm remembering correctly for most. So for our low slope or flat roofs, which really aren't flat, they do have a slight slope to those. We're going to have a couple different materials. Obviously, they would need to be sealed really well to stop any rain or moisture or melting snow or things to get through it. And we're going to see those made from a thermoset single ply roof or a thermoplastic single ply roof. Those are just really different plastic or rubberized materials used in those roofs so that we can seal them and make sure that they're not going to get any moisture through them. These roofs should have a minimum slope of 1/4 inch per 12 or 1/4 unit per 12 units. And that would be a 2% slope. And that does allow for drainage. It would appear very, very flat. And it's what we'd see on maybe a school. You think it's a flat roof, but it does have a slight slope, and that's to help with drainage when it does rain or when we have snow melting and things of that nature. So now we're going to try to identify some of these roof styles. So what type of roof is this? Hopefully everybody's saying the low slope or flat. All right, what about this one? It's a combination. It's a combination of shed roofs. This one? Hopefully you're saying gable. This would be probably the more common roof type. And again, that's going to come down to the cost and efficiency. It's one of the more simple roofs, but it does what it's supposed to. All right, here's one that might be a little bit harder to remember. We have all of our sides sloping towards the center. This one was our hip roof. If you look close, this is actually a hip valley, and I believe to the left side would be a gable. But it's definitely a hip with a valley. This one, we see the dormer added. So what type of roof was it added with that dormer? And we also see the valley to the left side. So hopefully you're saying gable with dormer and really with a valley as well. What about this one? Very similar to the barn style. Everybody's saying gambrel. So with this one here, we see the gable on the front, and we also see the hip. For them to come together, we know we would have a valley. So it's really a hip with a valley and gable. All right, so now we're going to jump into the architectural model. You guys are going to watch me do a demonstration of that and the rest of this video, and you guys are going to get a chance to try to create one yourself. All right, here we go. All right, first we're going to talk about a few of the things you're going to need to create this architectural design model. And we'll talk a little bit about safety as well. But some of the things you're going to need is the foam core or cardboard to create the actual model. Either one of those would work. If you're in class and you'd like some foam core, just ask. If you're at home and you're a virtual learner and you need some, you could also send me an email and I'll get some sent to you, but I can't promise how much lag time there'll be before things get sent home. So some of the things you're going to need, other things you're going to need, tape, some scissors, maybe a utility knife if you've been trained on it. I know the students I'll have in class will talk about how to correctly use one of those. If you're one of my virtual learners at home and you're not in class for the safety lesson, please use scissors. You'll also need a pen or a pencil and a ruler. And in the end, you'll need a marker to label the type of roof that you have. So as a reminder to the people that might be using an X-Acto or utility knife, as we talked about in class, please do not cut towards yourself. That also means do not cut on your lap. Your lap is certainly not a workbench. If you're cutting on top of a table or a nice surface, please make sure you have a scrap block down below that so you do not destroy your tables. All right, and now we will move on to the process. Please refer to the activity document in task 3 for the dimensions, but the dimensions I used, and we'd like to keep them consistent so everybody's doing it the same. The wall heights are going to be 5 inches. The length of your long side will be 8 inches, and your short side will be 6 inches. And you'll see this come together here in a minute. So the first thing I'm doing here is kind of mapping out a section. I'm going to fold it and show you how to do those creases in a minute. So you can do it as one long piece. You are welcome to do it as smaller pieces and tape them together. I still tape my edges even though it's one large piece just to make it look cleaner. And you'll see me do that here in a second. So here I am cutting out that long section. I'm going to fold to make my square shape in a second. Now I'm going to score each of my lines. I'm not going to go all the way through. These are just going to be a fold point. If you cut all the way through, it would separate those pieces. But if you're careful and you just score that part way through the material, you can do that with scissors as well. Then you can fold it and keep it all together. Once I make my folds, I'll start adding some tape to those corners to bring it all together, as you can watch here in the next minute or so. At this point, I'm going to come back in. I'm going to add some tape. I'm overlapping half the tape with one side and the other half on the other to bring it together. And then I'm going to use some tape on the rest of the corners for consistency and to help clean it up a little bit, as you see me adding to this right now. Once I get the last piece on, I will try to square it up and get it in the orientation that I'd like. Alright, the next thing I'm going to do is measure for my roof. I'm going to start by measuring from the top of the wall to the top of the peak. On one side I end up with 4.5. So when I double that, I get 9, and I want an inch overhang on each side. So I added 2 inches. So I had 11 for that dimension, and then I had 8, but I'm going to add 2 inches, 1 inch for each overhang, for a total of 10 inches. So I had 11 by 10 for a square for my roof, and you can see me cutting that out, or measuring to cut out right here. Now I'm going to come back through. I'm going to get my tape, and I'm going to tape that roof on by turning the model upside down so I can access it from the inside and keep that tape on the inside so we don't see it from the outside and create a mess. At this point, all I have to do is come back in and label my roof type, and you're all done.